Welcome to the Explainer, everyone. I'm so stoked you're here, because today we're tracing the absolutely wild journey of how our digital world is saved. We're going from the clunky, spinning metal platters of early tech all the way to the invisible, weightless cloud storage we use today. Seriously, if you've ever wondered where your data actually lives when the screen goes black, you're in the right place. Let's get moving. Here's a quick roadmap of what we're covering. 1. Saving your digital world. 2. Hard disks, the spinning pioneers. 3. Optical disks, lasers and pits. 4. The solid-state revolution. 5. Data in the cloud, and we'll wrap up with 6. The great storage showdown.
All right, section 1, saving your digital world. Let's jump right in.
Okay, before we get to the flashy hardware, we gotta nail down exactly what secondary memory is. Simply put, it's your auxiliary or backup storage. It's the hardware that permanently locks in your data and instructions even when the power's completely off. Your computer's primary RAM is lightning fast, sure, but it's volatile. It needs continuous juice. Secondary memory? That's the vault.
Think about it for a second. What actually happens to your data when the power suddenly cuts out? Boom, everything gone. Without secondary storage, every document, every photo, every high score would literally vanish into thin air the second you hit the power button. Solving that problem? It took decades of some truly mind-blowing engineering.
Which brings us to section 2, hard disks, the spinning pioneers.
Take a look at this classic hard disk drive, or HDD. Notice how the internal parts are laid out here. You've got physical aluminum platters coated with a ferromagnetic material. The data is magnetically written onto these circular metal disks. And the crazy part is how mechanical it all is. When you save a file, there's a literal tiny arm that physically moves across those platters to write the data. And watch this number, 7,200 RPM. To read and write, those platters are spinning like crazy under the hood. Drive speed is measured in revolutions per minute, just like a car engine. Most standard HDDs spin at 5,400 or a dizzying 7,200 RPM. Think about that. A metal disk inside your laptop just spinning thousands of times a minute so you can open a PDF. Wild, right?
But, relying on moving parts has some big trade-offs. The upside? Vast capacity, and they're super cheap. You can get anywhere from 500 gigs to a staggering 18 terabytes of space. But the speed is, well, it's moderate. You're maxing out between 80 and 160 megabytes per second. Plus, if you drop one, yeah, that tiny moving arm can crash right into the platters and permanently wipe your data. Not great.
Moving on to section 3, optical disks, lasers, and pits. Time to ditch the magnets for lasers. Let's animate this timeline to see how fast things moved. In 1980, Philips develops the compact disc, the CD. Total game changer for audio and software. Then, fast forward just 15 years to 1995, a huge coalition, Philips, Sony, Toshiba, Panasonic, they drop the DVD, the digital versatile disc. And this comparison completely explains why DVDs took over overnight. Both use laser light to read tiny reflective bumps, or pits. But look at the capacity leap. A CD gives you about 700 megabytes. Nice for an album. But a DVD? Up to 17.08 gigabytes. They achieved this massive jump by utilizing multiple layers for data. Single side, double layer, the whole shebang. It literally made high-quality video storage possible.
All right, section 4, the solid-state revolution. Because eventually, even lasers weren't fast enough.
Say hello to the solid-state drive, or SSD. Look at the circuit board here. No metal platters, no moving reading arms. It's totally solid. SSDs rely on highly advanced semiconductor chips, NAND flash memory, to hold your data. This was an absolute paradigm shift for laptops and ultrabooks. The SSD advantage is literally night and day. Check out these stats. Speed? We're going from roughly 160 megabytes per second on hard drives to anywhere from 200 to over 3,500 megabytes per second. Lower latency means everything loads instantly. And durability? Since there are zero moving parts, it handles physical shocks effortlessly. You drop an SSD, your data's probably fine. And that exact same NAND tech, it was scaled down to create the flash memory you've definitely got in your pocket right now. Think USB pen drives, SD cards. They're ultra-portable, non-volatile, and electronically erased in blocks. It's basically the ultimate, highly durable storage vault for your phone or digital camera. Next up, Section 5, Data in the Cloud.
This is where hardware becomes totally invisible.
We're moving away from hardware we can physically hold straight to third-party cloud providers. You definitely know them: iCloud, Dropbox, OneDrive, Google Drive. The real magic here is automatic synchronization across all your devices without a single cable.
But let's demystify this for a sec. Quote, online storage of data on remote servers accessed over the internet. That's all the cloud actually is, folks. It's not magic. It's just taking your files off your local drive and beaming them over the internet to sit on massive high-speed server racks in someone else's warehouse. Super scalable, easily accessible, and an incredible backup method. All right, let's bring it all together. Section 6, the Great Storage Showdown.
Let's break down this summary table. If you're building a massive media archive and need a ton of cheap space, HDDs are still the king, hitting up to 18 terabytes, even if they're a bit fragile and slow. Need to run heavy software lightning fast? SSDs absolutely crush the speed test, over 3,500 megabytes per second. And they're crazy durable, though pricier. And sitting comfortably in the middle is flash memory. Highly portable, durable, and perfect for your everyday carry.
So, we've gone from giant spinning disks down to microscopic silicon, and now out into the invisible cloud. Which leaves us with this question. With storage getting faster and smaller by the minute, will local drives eventually vanish entirely? Are we moving to a future where our devices have zero secondary storage and we're just permanently tethered to the cloud? It's pretty wild to think about. Thank you so much for joining me on this explainer today. Keep learning, and I'll catch you on the next one.